Next from the College of Engineering, Sherif El-Tawil and his team, who surely deserve a special award for the best project title with Dancing with Steel Girders. Congratulations, Sherif.
Virtual reality is a way to embed you inside a computer simulated environment. It is most famously used in games, so many gamers are familiar with this. And that's another appealing aspect to what we're doing, is that it feels very much like you're in a game and you're controlling things and kind of looking from various angles. So the idea is to basically immerse you inside this environment where you can feel it to be almost real. Over the years, I found it very difficult to explain 3D concepts to some of my students. How do complex connections get put together? How do certain structural members, when they're loaded, how do they buckle and deform? And so over the years, with my research going in a particular direction, I started to merge both of them together and using virtual reality to show some of those very complex three-dimensional effects. And so rather than have a static like model that doesn't change and you show it to students year after year, now our models can actually be dynamic. We can take the students into the 3D lab and they can explore an infinite variety of configurations. And so this is, in a nutshell, kind of what we were doing. We've deployed this in the steel design course, and the steel design course is where we have some of these complex connections taking place, members coming in at various angles and being connected using bolts and welds. It's kind of hard to understand and to describe to students because you're trying to describe a 3D environment on a 2D board, right? So you have to draw it on a board, and that's kind of immediately you know that there's a problem there. In that course as well, we see this complex phenomena of buckling. So buckling is where you take a ruler and you push on it, and so it kind of rises up, you release it, comes back. But in a real structure, the buckling can take much more complex shapes, and that is kind of challenging to tell our students about. They liked it very much because, again, they feel like they're in a gaming situation. I mean, they were zooming all over the place, they were shrinking the structure, they were making it very large. And that's the beauty of virtual reality, is you can do all of this. You can be a giant looking down on a microscopic structure, or you can be an ant climbing up the structure, looking at it from various angles. So it's really, really cool. I love playing with it myself. We invited the students who did not do very well in a portion of the class that was designed to test them on these 3D issues to come back and use this technology. And they did, and we showed that it did improve their grades. And so we feel we are going to deploy it, I think, full-time next year, or I guess next fall. And we plan to deploy it on a regular basis after this. I think this could be deployed in many engineering courses because by nature, engineering courses always involve these complex three-dimensional configurations. And so within civil engineering, I already see it in deployable in several courses. Whatever the discipline is, I think there are always these challenging 3D situations which this technology could be helpful with. If they get in touch with us, we can work with them in the 3D lab to put things in a particular configuration that they can easily use it. And so we've written software and we've had programmers work with us to allow this technology to be, I guess, accessible to most people. And that is kind of what we've been doing. So if they get in touch with us, we'll try and fit things for them so that they could use it.